Cat food. Cat food is food for consumption by cats. Cats have specific requirements for their dietary nutrients. Certain nutrients, including many vitamins and amino acids, are degraded by the temperatures, pressures and chemical treatments used during manufacture, and hence must be added after manufacture to avoid nutritional deficiency. The amino acid taurine, for example, which is found in meat, is degraded during processing, so synthetic taurine is normally added afterwards. Long-term taurine deficiency may result in retinal degeneration, loss of vision, and cardiac arrest. Contrary to popular belief, most cats dislike insects and probably eat them mistakenly, which may cause gastrointestinal upset and vomiting. History. The idea of preparing specialized food for cats came later than for dogs. See dog biscuits and dog food. This was likely due to the idea that cats could readily fend for themselves. In 1837, a French writer Moni de Mornay critiqued this idea. In 1844, another French writer expanded on this idea. He goes on to say that it is all the more unreasonable to expect a cat to live from hunting and that cats take mice more for amusement than to eat. A good cat takes many and eats few. By 1876, Gordon Staples emphasized the need to give cats particular food. In the same year, an advertisement for Sprat, better known for making dog food, said that their cat food entirely superseded the unwholesome practice of feeding on boiled horse flesh, keeps the cat in perfect health. And, in another book on cats, Staples recommended the company's food. Sprat, which began by making dog biscuits, appears to also have been the first commercial producer of cat food. During the 19th century and early 20th centuries, meat for cats and dogs in London, frequently horse meat, was sold from barrows, handcarts, by itinerant traders known as cats' meat men. Natural diet. Cats are obligate carnivores, meaning, they are true carnivores and depend upon the nutrients present in animal flesh for their dietary needs. Even domesticated cats will relish freshly killed meat from rodents, rabbits, amphibians, birds, reptiles and fish, but cats are also opportunistic feeders and will readily take cooked food as well as dried cat food when offered, if that food is palatable. The natural diet of cats therefore does not include any vegetable matter, although cats have been known to eat certain plants and grasses occasionally, usually as an emetic. Cats cannot synthesize some essential nutrients required for survival, including the amino acids taurine and arginine, so these nutrients must be sourced from fresh meat in the natural diet. Cats lack the specific physiology to extract nutrients efficiently from plant-based materials, and require a high-protein diet, which is why high-energy meats from freshly killed prey are optimal foods. Commercial cat food. Most store-bought cat food comes in either dry form, also known in the US as kibble, or wet canned form. Some manufacturers sell frozen raw diets and premixed products to cater to owners who feed raw. Dry food. Dry food, 8 to 10% moisture, is generally made by extrusion cooking under high heat and pressure. Fat may then be sprayed on the food to increase palatability, and other minor ingredients, such as heat-sensitive vitamins, which would be destroyed in the extrusion process, may be added. Dry food is most often packed in multi-wallpaper bags, sometimes with a plastic film layer. Similar bag styles with film laminates or co-extrusions are also used. Wet food. In much of Europe, the UK and the US, canned or wet food, 75 to 78% moisture, generally comes in aluminum or steel cans in 3 ounces, 85 grams, 5.5 ounces, 156 grams, and 13 ounces, 369 grams, sizes. It is also sold in foil pouch form. Vegetarian or vegan food. Even though cats are obligate carnivores, there are vegetarian and vegan cat foods available. Vegetarian cat food must be fortified with nutrients such as taurine and arachidonic acid that cats cannot synthesize from plant materials. Some vegetarian cat food brands in the USA are labeled by their manufacturers as meeting OFGO's cat food nutrient profile. Low protein. Although the diet of a healthy cat should be high in protein, at times it is medically necessary for a cat to eat a low-protein diet. For cats living with chronic renal disease, decreased dietary protein appears to slow the disease's progression by decreasing the workload on the kidneys to excrete protein waste products. Less protein also means less need for the excretion of protein itself through the filtration mechanism of the kidney, which helps preserve kidney function. Unfortunately, low-protein diets are not as palatable to cats as diets high in protein. Raw food. Raw feeding is providing uncooked ingredients to cats. Most of the diet will consist of animal-based ingredients, though fruits, vegetables and supplements are often added. Commercial raw food is mainly sold in three formats: fresh, frozen and freeze-dried. Thawing and rehydration are necessary before feeding frozen and freeze-dried food respectively. Many available commercial diets are OFCO certified in meeting the nutrient requirements of the cat. Some diets may be formulated for all life stages, or they can also be OFCO certified for adult maintenance or growth and gestation/lactation. Many people feed their cats raw food believing that it mimics the prey diet that wild cats would consume. Firm believers report that such a diet can bring about many health benefits, such as a shinier coat, cleaner teeth and an improved immunity to various gastrointestinal ailments, with diarrhea and constipation being the most common, as well as an increase in energy and a decrease in bodily waste odors, although no scientific evidence exists to prove these claims. Commercial raw diets can undergo high-pressure pasteurization, HPP, a process which kills bacteria and pathogens, including salmonella, using high water pressure. This technique is USDA approved and allows raw food to remain uncooked while greatly improving its safety and shelf life. However, every year, many commercial raw pet foods are recalled due to various bacterial contamination, implying that feeding raw comes with a risk. Weight management. Weight control simply means ensuring an energy balance. Energy in equals energy out. Weight gain means more energy is being consumed than is being expended in exercise and other functions. A weight management diet is designed to allow fewer calories to be consumed in a larger volume of food, allowing for less risk of an energy imbalance. Adult cats should be fed a diet that promotes maintaining a healthy weight, while at the same time meeting the individual taste preference of the cat. Cats generally prefer to eat smaller meals more frequently, which can lead to less weight gain compared to cats that are fed free choice, always available, food. Meanwhile, some cats adapt to free choice feeding and can maintain normal body weight with no weight gain. In general, indoor cats have less opportunity or need for exercise than outdoor cats. Indoor cats are much more prone to weight gain. For indoor cats, there are a variety of choices to promote exercise, including various cat toys designed to stimulate chase and play behaviors. Overall, if an adult cat cannot maintain normal body condition on a free choice feeding diet, despite exercise levels, portion-controlled feeding is recommended. Many pet cats are fed energy-dense, high-carbohydrate diets, which provide much more energy than needed. This is a major issue with indoor cats as it has been shown to lead to obesity. To prevent cats from becoming overweight, owners should be more inclined to implement weight control diets, which provide the cat with nutrient-dense, low-energy ingredients. Studies show that cats fed lower energy diets have significantly reduced incidences of obesity, as the typical indoor pet cat does not need more energy than their resting energy requirement. For an average cat weighing 10 to 11 pounds, about 5 kilograms, it would have a resting energy requirement of 180 to 200 kilocalories/day. Along with energy input and output, specific nutrients can be important in weight control diets. Fiber is an important component that helps control weight, along with various other benefits. A source of soluble and fermentable fiber helps to increase the movement of digesta through the gut and decrease gastric emptying. This helps to increase satiety in cats, potentially decreasing feeding rates and voluntary energy consumption. Fermentable fiber promotes healthy mucosa and commensal bacterial growth and improved digestion/nutrient absorption. Prebiotic fibers like fructooligosaccharides, FOS, and mannan oligosaccharides, MOS, decrease the number of pathogenic bacteria and increase the number of beneficial bacteria in the gut. They also help to maintain microbial balance and a healthy immune system. Fiber is fermented in the colon to produce short-chain fatty acids which can be used as an energy source. Fermentable fiber has been demonstrated to enhance general health and decrease inflammation. Furthermore, non-fermentable fiber is critical to the formation of well-formed stool, and has been known to increase diet bulk while decreasing caloric density. Insoluble fiber has been proposed to regulate appetite by releasing hormones that reduce hunger. Sources of fiber commonly added in weight management cat food include beet pulp, barley, psyllium and cellulose. Another nutrient important for weight control diets is protein and its component amino acids. Felines, being obligate carnivores, require a natural diet of animal products which consists of protein and fat, i.e. muscle, organs and animal tissue. Dietary protein supplies amino acids that can be utilized and metabolized as energy over fat when provided, even though protein is not stored in the body the same way as fat. Dietary fat is more efficiently converted to body fat than protein, if an animal is consuming more than its energy requirement, and if the excess energy is provided by fat, more weight will be gained than if the excess calories are coming from protein. Dietary protein also improves satiety during feed, resulting in decreased overconsumption of food. The protein content of the diet is a key factor in building and maintaining lean body, muscle, mass, which is an important aspect of weight control. Lean body mass maintenance is regulated by protein intake, but more importantly is regulated by exercise. Limited protein and amino acids in the diet will limit lean body mass growth, but exercise or lack of exercise will allow growth or shrinking of muscle. Successful weight control involves maintenance of healthy adipose tissue levels, but most importantly maintenance of lean body mass. Lean muscle is the driver of basal energy metabolism and aids in the use of energy. When sufficient levels of fat are provided, fat will be used by the body as an energy source, but only when there are insufficient levels of protein. An important amino acid that is incorporated many weight loss/weight control diets is L-carnitine. This is a vitamin-like substance that is found in animal protein, and is the only form found in nature as well as being the only biologically active form. It can be found in ingredients commonly used in more commercial pet foods, but specifically weight management/weight loss diets. L-carnitine is involved in many biological pathways, more specifically fatty acid metabolism, allowing for the conversion of long-chain fatty acids into energy. The introduction of L-carnitine ensures rapid transport and oxidation of fatty acids as well as efficient usage of dietary fatty acids and protein. Supplementary L-carnitine is used more often in weight loss diets, since its benefits mainly involve fatty acid metabolism to control weight loss. However, since weight control is, in essence, a prevention stage in overall weight management, it still has value in weight control diets in preserving and building lean body mass and inhibiting the storage of excess dietary fat. The majority of studies focusing on supplementary L-carnitine use look at its benefits for weight loss, including its effect on metabolic rate and fatty acid oxidation. At the same time, these studies still show similar results that prove their effects of controlling fatty acid metabolism for weight control, to avoid the need for weight loss diets. Packaging and labeling. In the United States, cat foods labeled as complete and balanced must meet standards established by the Association of American Feed Control Officials, AAFCO, either by meeting a nutrient profile or by passing a feeding trial. Cat food nutrient profiles were established in 1992 and updated in 1995 by the AAFCO's Feline Nutrition Expert Subcommittee. The updated profiles replaced the previous recommendations set by the National Research Council, NRC. Certain manufacturers labeled their products with terms such as premium, ultra-premium, natural and holistic. Such terms currently have no legal definitions. However, while most of the food supply comes from within the U.S., the FDA ensures that standards are met within our borders even when components come from countries with less stringent levels of safety or label integrity. Dry cat food, kibble, is most often packed in multi-wallpaper bags, sometimes with a plastic film layer. Similar bag styles with film laminates or co-extrusions are also used. Wet cat food is often packed in aluminum cans or steel cans. Packaging regulations for cat food are often very similar to corresponding regulations for human foods. Energy requirement. The energy requirements for adult cats range from 60 to 70 kilocalories metabolizable energy/kg body weight, BW, per day for inactive cats to 80 to 90 kilocalories/kg BW for active cats. Kittens at 5 weeks of age require 250 kilocalories/kg BW. The requirement drops with age, to 100 kilocalories/kg BW at 30 weeks and to the adult requirement at about 50 weeks. Gestating cats require approximately 90 to 100 kilocalories/kg BW, up to 1.5 times the energy required of normal adult maintenance. Lactating cats require 90 to 270 kilocalories/kg BW depending on litter size, and they require between 2 and 2.5 times the energy needed for normal adult maintenance. Nutrients and functions. Vitamin deficiencies can lead to wide-ranging clinical abnormalities that reflect the diversity of their metabolic roles. 12 minerals are known to be essential nutrients for cats. Calcium and phosphorus are crucial to strong bones and teeth. Cats need other minerals, such as magnesium, potassium, and sodium, for nerve impulse transmission, muscle contraction, and cell signaling. Many minerals only present in minute amounts in the body, including selenium, copper, and molybdenum, act as helpers in a wide variety of enzymatic reactions. The table below lists the OFCO nutritional profiles for cat foods along with the roles of vitamins and minerals in cat nutrition according to the National Research Council. Diet and disease. Further information: cat skin disorders. Many nutrients can cause a variety of deficiency symptoms in cats, and the skin is a vital organ that is susceptible to dietary changes in minerals, protein, fatty acids, and vitamins A and B. Cats show dietary inadequacies in their skin through excess or inadequate oil production, and skin toughening. This results in dandruff, redness, hair loss, greasy skin, and reduced hair growth. Skin and coat diets. Good overall nutrition is needed along with a well-balanced diet. If problems with a greasy and dull-looking coat or flaky skin arise, this could be signs of a greater internal issue. It is possible that the cat is not getting the proper nutrients in the proper quantities in their diet. This can be seen more commonly with cats that eat diets that are of poorer quality. Zinc. Zinc's connection to skin and coat health is due to its influence on regulating cellular metabolism. Zinc also supports proper immune function and suitable activity within the inflammatory response. Deficiencies result in disorders of the skin and poor immune functioning. When zinc is supplemented in diets, skin scaliness was decreased. Dietary sources include poultry, red meat, and eggs. Copper. One of the many functions of copper is to assist in production of connective tissue and the pigment melanin. A deficiency in dietary copper is also related to collagen abnormalities, hypopigmentation of the skin, and alopecia. Sources for cats include liver and supplements in the forms of copper sulfate and cupric oxide. Selenium. Selenium works with vitamin E as antioxidants to handle the free radicals that are damaging to the body and the skin. Selenium also plays a role with other antioxidants to help maintain cell membranes, which provides further protection from free radicals causing oxidative stress. Oxidative stress plays a role in development of skin diseases. Dietary sources of selenium are naturally occurring in selenomethionine and tuna. Fatty acids. Fatty acids are an important part of the cat's diet. Some are more important than others with respect to the cat's diet, and these are known as essential fatty acids. Essential fatty acids are nutrients that cats are unable to produce at all or in sufficient amounts to reach their needs. There are 3 essential fatty acids that should be included in a cat's diets, and they are alpha-linolenic acid, linoleic acid, and arachidonic acid. Alpha-linolenic acid is an omega-3 fatty acid that is important to cats as it aids in the maintenance of their skin's water barrier. As the water barrier is important to the cat's skin, ingredients that are high in alpha-linolenic acid, such as flaxseed, should be included in the cat's diet. Another source of omega-3s are in fish oil. However, it is higher in eicosapentaenoic acid, EPA, and docosahexaenoic acid, DHA, which can be important for cats as they have anti-inflammatory properties. Linoleic acid is an example of an omega-6 fatty acid that also helps with the health of the cat's skin by maintaining the integrity of their epithelial tissues. Linoleic acid is commonly found in plant-based oils. An ingredient that is commonly used as a source of linoleic acid is sunflower oil. Arachidonic acid is also essential to cats because they are unable to create it from linoleic acid due to an absence of the delta-6 desaturase enzyme. It's important for their skin for the same reason as linoleic acid and can be found in ingredients such as animal fat. Vitamin A. Vitamin A is a crucial nutritional component in the maintenance of feline skin and coat health. In addition to its many other functions, vitamin A plays an important role in the keratinization of the skin, hair and nails, along with assisting in the development of various epithelial tissues throughout the body. The cells making up the epithelial tissues of the skin, respiratory and gastrointestinal tracts rely on vitamin A to successfully complete the process of mitosis in order to preserve these tissues and repair any damages. The mucus-secreting cells of the respiratory and gastrointestinal epithelium also specifically require vitamin A to successfully produce a specialized protein referred to as mucoproteins, which aid in maintaining the health of these tissues. Unlike most other mammals, the cat is unique in that they are unable to transform B-carotene to vitamin A and therefore explicitly require active forms of vitamin A which are only found in animal products. This difference in metabolism is due to very low levels of activity of the enzyme beta-carotene 15-dioxygenase in feline species. The nutrient profiles developed by OFCO currently advise a minimum of 3,332 IU/kg of vitamin A on a dry matter basis included in adult diets and 6,668 IU/kg in the diets of growing kittens as well as pregnant or lactating female cats. Common ingredients which help to incorporate the proper levels of vitamin A into feline diets include various types of liver as well as fish oils. Vitamin E. Vitamin E is an essential nutrient which needs to be included in the feline diet in order to protect the lipid components within cellular membranes of various tissues in the body. Vitamin E is able to accomplish this through working with selenium and acting as an antioxidant to prevent free radicals from interacting with these fatty acid membrane components, resulting in reduced levels of oxidative stress. This is particularly important in the skin as various oxidative environmental components can have very damaging effects if not protected by vitamin E. The nutrient profiles developed by OFCO currently advise a minimum dry matter inclusion of 40 IU/kg of vitamin E in the diet of cats throughout all stages of development. Lipid metabolism is also a major contributor of free radicals, leading to an increased dietary requirement of vitamin E as the levels of polyunsaturated fatty acids in the diet increase. Ingredients such as wheat germ as well as certain plant oils contain high levels of active vitamin E and are commonly added to feline diets which are carefully stored in order to prevent oxidative destruction of vitamin E prior to consumption. B vitamins. Biotin. Biotin can be provided in feline diets through the addition of cooked eggs, liver, milk, legumes or nuts. Microorganisms living in the gastrointestinal tracts of cats are also able to synthesize and supply an alternative source of biotin if proper nutritional requirements are met. Its main function in metabolism is to operate as a coenzyme for essential carboxylation reactions throughout the body. However, it has also been shown to aid in the management of certain skin diseases in cats. Biotin is recommended by OFCO to be included in feline diets at a minimum level of 0.07 mg/kg on a dry matter basis throughout all stages of development. Vitamin C. Unlike humans, felines are able to utilize simple sugars glucose and galactose in a specialized pathway which occurs in the liver, referred to as the glucuronate pathway. This pathway ultimately produces the active form of vitamin C and maintains it at an adequate level, therefore it does not need to be separately included in their diet. Low-protein therapeutic diets in relation to the kidneys. Therapeutic diets with low protein have been adopted by a number of big pet food manufacturers with the goal of supporting renal health for cats with chronic kidney disease, CKD. Chronic kidney disease or CKD is a highly prevalent condition in the feline population and is most common in the aging and older domesticated feline. It has been shown that the lifespan of cats experiencing CKD can be extended by as much as 2 years when receiving therapeutic diets rather than regular maintenance diets. The normal functions of the kidneys are to control a normal fluid balance and to excrete waste products from the blood into the urine. One of the biggest concerns associated to CKD is to reduce the amount of stress put on the kidneys to process and excrete nitrogenous wastes from the body. Low-protein diets are a good choice for cats experiencing CKD as it lowers the amount of nitrogenous waste in the body, helping to decrease the strain put on the kidneys. Nitrogenous wastes are produced by the body when amino acids obtained from the digestion of protein are metabolized to make energy. The exact level of protein that is needed for therapeutic CKD diets is unclear, as sufficient protein is needed for maintenance while still offering a lower nitrogen level for the kidneys. Low-protein diets can be formulated as a wet or dry food, with the main difference being the moisture content. These diets are formulated specifically to support the kidneys and urinary tract and also to help prevent the progression of CKD. There are certain dietary parameters that these diets follow on top of low protein, such as low phosphorus, high energy density, a higher fat content and inclusion of omega-3 fatty acids to aid the kidneys in different ways. Formulating the diet to have low phosphorus is very important, as restricting the amount in the diet has been proven to decrease the progression of CKD. The reason that plasma phosphorus concentration should be kept low for low-protein therapeutic diets is because phosphorus can be deposited into soft tissues and become mineralized, which can cause kidney damage. Formulating these diets with higher amounts of fat is important to make sure the food is palatable in the absence of protein and promote an increased caloric intake. The higher fat content will also spare the use of protein for energy and help decrease stress on kidney. This inclusion of higher fat content also increased the energy density of the food, which is important for cats with decreased appetites. Omega-3 fatty acids are included in therapeutic diets because of their anti-inflammatory properties to aid the diseased kidneys. Low-protein diets in relation to the liver. Low-protein diets should not be fed to cats with a liver condition known as hepatic encephalopathy because severe protein restriction can be detrimental to animals with this condition. Cats with this condition should be fed a diet with high-quality protein sources that have adequate amounts of the amino acids taurine and arginine. High-energy diets. A high-energy diet is generally high in fat. Compared to carbohydrates and protein, fat provides much more energy, at 8.5 kilocalories/g. High-energy diets generally have a fat content greater than 20% on a dry matter basis. A high-energy diet is appropriate for cats who are undergoing growth, recovering from illness, are pregnant or lactating, as their energy requirements are higher than otherwise. A lactating or gestating cat requires a nutrient-dense and highly digestible diet to withstand the high levels of stress being placed on her body. These conditions are found in cat food that is formulated for growth, performance, or high energy during all life stages. To maintain a neutral energy balance and thus maintain body weight, energy intake should increase with energy expenditure. Studies that relate the number of meals offered to cats per day to their daily activity levels have shown conflicting results. It has been shown that cats offered 4 meals a day or a random number of meals a day have similar energy levels, greater than those fed only 1 meal per day. It has been postulated that this increased energy level could be due to purported spikes in activity before being fed, known as food anticipatory activity. Other studies on female cats have found that increasing the daily amount of food may actually decrease their daily activity levels. The age, sex, and whether cats are intact or have been spayed/neutered are all factors controlling activity level. As cats age, there is evidence that their metabolic energy requirements may increase, especially after 12 or 13 years old, but other evidence suggests that metabolic energy needs are not dissimilar at different ages. Furthermore, it has been shown that cats over 12 years old are more likely to be underweight than younger cats, so a high-calorie diet may be appropriate to treat weight loss, and thus to maintain an appropriate body condition score. Weight loss can occur when the cat expends more energy but does not increase its food energy intake. It has also been demonstrated that as cats age, they are less able to digest and thus absorb dietary fats and proteins. Pregnancy and lactation are strenuous periods on the female cat. During pregnancy, a cat should gain 38% of their body weight by the time they are ready to give birth. It is recommended that a cat's diet should contain 4,000 kilocalories per day while pregnant. During lactation, it is recommended that the cat consumes 240 to 354 kilocalories/mi kg of body weight. Studies show that increasing the intake of food for a pregnant animal in order to help it gain weight can have negative effects. It is acknowledged that rather than increasing intake, feeding a highly energy-dense food is a way to ensure that the female cat, or queen, receives adequate energy and nutrient requirements are met. It has been found that nutritional support consistent with the resting energy requirement, RER, soon after surgery or the onset of illness decreases the mortality rate and the duration of hospitalization in cats. A recovering cat needs enough energy, calories, as well as more protein and fats. Critical care diets are formulated to be highly palatable and digestible, as well as high energy density. This limits the mass of food required to be consumed to meet the RER. This type of high-energy diet has proven to be very important in the nutritional support of post-operative and ill cats. Vegan and vegetarian diets. Vegetarian or vegan cat food has been available for many years, and is targeted primarily at vegan and vegetarian pet owners. While a small percentage of owners choose such a diet based on its perceived health benefits, the majority do so due to ethical concerns. Despite this, most vegans who feed their cats a vegan diet believe that a vegetarian diet is healthier than a conventional diet. There is much controversy over feeding cats a vegetarian diet. While there is anecdotal evidence that cats do well on vegetarian food, studies on commercial and homemade vegetarian cat foods have found nutritional inadequacies. As obligate carnivores, cats require nutrients, including arginine, taurine, arachidonic acid, vitamin A, vitamin B12 and niacin, found in meat sources. Plant sources do not contain enough of these. Vegetarian pet food companies try to correct these deficiencies by adding synthetically produced nutrients. According to the United States National Research Council, Cats require specific nutrients, not specific feedstuffs. Cats on a vegan diet can develop abnormally alkaline, high pH, urine as plant-based proteins are more alkaline than the meat-based foods which cats have evolved to eat. When the urine becomes too alkaline, there is an increased risk of formation of struvite, also known as magnesium ammonium phosphate, bladder crystals and ore stones. Calcium oxalate stones can also occur if the urine is too acidic. Such stones can create irritation and infection of the urinary tract and require veterinary treatment. Organizations that advocate vegan or vegetarian diets for people have split opinions regarding vegetarian or vegan cat food. The International Vegetarian Union, the Vegan Society and PETA are some of the organizations that support a vegan or vegetarian diet for cats. But the Vegetarian Society suggests people consider carefully and that many cats will not adjust to a vegetarian diet. They provide a list of necessary nutrients that would need to be supplemented, and recommend that those who want to try should consult a veterinarian or animal nutritionist. The Animal Protection Institute also does not recommend a vegetarian diet for cats, and cautions that dietary deficiencies may take months or years to develop and may be untreatable. They do not recommend relying on supplements, because they may not contain necessary cofactors and enzymes and have not been studied for long-term implications. The animal welfare organization American Society for the Prevention of Cruelty to Animals, although suggesting a supplemented vegetarian diet for dogs, recommends against vegetarian and vegan diets for cats. The Association of Veterinarians for Animal Rights, now Humane Society Veterinary Medical Association, accepts that a plant-based diet can be nutritionally adequate, but stated in August 2006 that such diets cannot at this time be reliably assured. This position was based on a 2004 study demonstrating that if both of the two commercially available vegetarian cat diets tested against the OFCO standard were nutritionally deficient. The formulation error in one of these diets was promptly identified and corrected. Nevertheless, it remains likely that formulation errors will result in nutritional deficiencies in a wide range of commercially available diets from time to time, whether meat-based, vegetarian or vegan. Hence, regular, at least, annual, veterinary checkups of all companion animals is recommended, and brands may be occasionally varied. Even when adequately supplemented, vegetarian diets may present other risks, such as urine acidity problems. While there are anecdotal reports linking a vegetarian diet with urinary tract problems, no documented case report or study exists. One vegan cat food manufacturer has stated that because of the relative acidity of meat to vegetable protein, some vegan cats suffer from. A quarter of cat owners who feed their cats a vegetarian diet perceive feline lower urinary tract disease as a health risk of such a diet. In 2006, the first study of the health of a population of long-term vegetarian cats was published in the Journal of the American Veterinary Medical Association. Most of the cats were fed a commercially available vegan diet, though 35% were allowed outdoors. The study consisted of telephone questionnaires of the caregivers of 32 cats, and analysis of blood samples from some of the cats. The blood samples were tested for taurine and cobalamin deficiencies. Cobalamin levels were normal in all cats. Taurine levels were low in 3 out of 17 cats tested, but not low enough to be considered clinically deficient. 97% of the caregivers perceived their cats to be healthy, including those with low taurine levels. Formulation of a nutritionally adequate vegan cat diet has its limitations. Recurring errors during formulation include insufficient protein content, insufficient calcium and phosphorus, along with an unbalanced calcium to phosphorus ratio which strays from the ideal range of 0.9 to 1 to 1.1 to 1. This is in addition to commonly occurring deficiencies of taurine, arachidonic acid, sodium, vitamin A, vitamin B12 as well as trace minerals. The reason for these dietary essential nutrients can be found in the physiology section of the cat page. Protein and fat content in a vegan cat diet can be balanced by the inclusion of tofu and yeast. Over-the-counter supplementation of vitamins and minerals in some cases may not meet nutrient requirements, as they come in varying amounts. As vegan diets are mainly derived from plant sources, some vitamins and minerals may be deficient, as plant sources do not provide adequate quantities. For instance, plant materials do not provide the preformed vitamin A which cats cannot synthesize, therefore supplementation is needed. As mentioned previously, arginine is a dietary requirement of cats, as it plays a critical role in bodily functions, referred to the physiology section in the cat page. Some ingredients of vegan cat diets that provide arginine are pumpkin seed, almond, soy flour, lentil seeds and oat flakes. See Table 1. The arachidonic acid added to cat foods typically comes from animal-based sources. In vegan cat diets, arachidonic acid can be added by including algal biomass or seaweed, but too much seaweed can be detrimental, as it may contain enough selenium to be toxic. A vitamin D3 source, lanolin, a constituent of sheep's wool, is often used to provide that vitamin. However, due to its animal origin, this would not be appropriate for supplemental use in a vegan cat diet, so a synthetic form of vitamin D3 is required. Vegan vitamin D3 can be synthesized by combining lichen, chicory extract and chamomile extract. Some vegan sources with high niacin content are brewer's yeast, oats, wheat flours, sunflower seeds and sesame seeds. OFCO requires cat food to have 60 mg of niacin per kilogram of cat food on a dry matter basis. Taurine can be biosynthesized or can be obtained in the diet by eating animal sources for food or algae. For cats, taurine is an essential amino acid as they cannot biosynthesize it from the amino acids methionine or cysteine, so they must obtain it endogenously. Enough synthetic taurine must be added to a vegan cat diet, as plant sources do not have taurine. Refer to the physiology section on the cat page. Low protein diets. Protein content between cat foods can vary anywhere from a low protein content of 26% to a content as high as 50% or above. The National Research Council, NRC, recommends protein content for cat diets is to be around 20% for adult maintenance and 21.3% for growth and reproduction. The Association of American Feed Control Officials, AFCO, recommendations however suggest a higher protein level of 26% for adult maintenance and 30% for growth and reproduction. Cats are obligate carnivores and require protein in their diet as an important component in energy metabolism and maintenance of lean body muscle. Cats are greatly adapted to a high-protein diet since they utilize protein as their main energy source, keeping carbohydrate utilization very minimal. In addition, cats will continue to metabolize protein even through protein deficiency by catabolizing lean body muscle. More specifically, cats, like most mammals, require the appropriate dietary amino acid balance to supply the essential amino acids, which are used for a multitude of body functions. It is crucial for low-protein diets to meet AFCO recommendations to ensure nutrient requirements are met. In general, lower protein diets tend to consist of a greater carbohydrate content, which means a potentially higher glycemic response in cats. Glycemic response refers to the response of glucose concentrations in the blood after a meal. Hexokinase is the enzyme cats use for metabolizing glucose because they do not possess the more efficient enzyme glucokinase. Cats are susceptible to prolonged postprandial glucose and insulin periods with high glucose peaks, resulting from the carbohydrate content of the diet. The degree of glucose peaks and the duration of the elevated glucose levels ultimately depends on the glycemic index of the carbohydrates used in the diet. Typically, a diet of low protein is replaced with added carbohydrate content. In some cases, fat can be added to lower protein diets in order to increase the energy density of the food product. A nutritional balance of amino acids is important in low-protein cat diets as cats are highly sensitive to deficiencies in arginine, taurine, methionine, and cysteine. Therefore, supplementation of these essential amino acids is important and commonly found in cat foods. The supplementation of polyunsaturated omega-3 fatty acids is common in products with lower protein as it plays a positive role in protecting the kidneys, which is an issue for many cats on a low-protein diet. Similarly, mineral composition is important, and low-protein diets result in a low phosphorus content that benefits the renal care and prevention of kidney disease. Benefits to low-protein diets. Feeding a lower protein content can help lower the amount of calcium being excreted in the feces and urine. It has been observed that urinary calcium concentrations and fecal calcium excretion is related to increasing protein concentration in the diet. Increasing calcium in the urine and feces can indicate increased calcium mobilization, for example of bone, within a cat instead of increased intestinal calcium absorption. Lower protein fed to cats can also decrease renal oxalate excretion, and therefore, decrease renal oxalate and calcium concentrations to support the decrease in urinary calcium concentrations, which contributes to the decrease in urinary relative saturations with calcium oxalate and can decrease the probability of a cat developing calcium oxalate stones. A lower amount of harmful bacteria is accumulated with a lower protein diet, which helps to increase the amount of positive bacteria present in the gut. Consequences of low protein diets. In low protein diets, unless the protein source is a high quality protein such as an animal-based protein, cats, and especially kittens, have been shown to develop retinal degeneration due to a deficiency in taurine, an essential amino acid for cats that is derived from animal protein. Since cats have such a high protein requirement, lower protein content, and thus lower amino acid concentrations, in the diet has been linked to health defects such as lack of growth, decreased food intake, muscle atrophy, hypoalbuminemia, skin alterations, and more. Cats on lower protein diets are more likely to lose weight, and to lose lean body mass. Low protein diets that are high in carbohydrates have been found to decrease glucose tolerance in cats. With a decreased glucose tolerance, clinical observations have confirmed that cats consuming large proportions of metabolizable energy, in the form of carbohydrates rather than protein, are more likely to develop hyperglycemia, hyperinsulinemia, insulin resistance, and obesity. Cats have a high priority for gluconeogenesis to provide energy for tissues like the brain. The rate at which it operates does not change despite having a low protein diet. Despite now being able to downregulate gluconeogenesis, cats are able to regulate their amino acid catabolism in response to a low protein diet, probably by increasing the synthesis of enzyme proteins without altering the catalytic rate. This collectively can make a cat wasteful of amino acids supplied in a low protein diet. Low protein diets have been shown to lower the levels of eosinophilic granulocytes in cats, which impacts the overall function of the immune system. Gastrointestinal health diets. The gastrointestinal tract is the source of nutrient absorption, making it integral to overall health. Therefore, feeding your cat for optimal digestive health is key for a healthy cat. Research shows fiber, prebiotics, probiotics, antioxidants, and fatty acids are important in maintaining gastrointestinal health. Fiber. The addition of fiber at optimal levels in a diet is essential for the normal function and health of the gastrointestinal tract. Dietary fibers are plant carbohydrates which cannot be digested by mammalian enzymes. These structural plant carbohydrates include pectin, lignin, cellulose, hemicellulose, mucilage, and gums. Different types of fibers have varying levels of solubility and fermentation. This ranges from pectin, which is highly fermentable, to beet pulp, which is moderately fermentable, to cellulose, which is non-fermentable. Non-fermentable fibers helps with satiety, maintenance of a normal intestinal transit time, and gastrointestinal motility, as well as increasing diet bulk. Fermentable fibers, on the other hand, are fermented to short-chain fatty acids by bacteria in the colon and have variable effects on gastric emptying. Moderately soluble fibers have been linked to increased colon weight as well as an increased mucosal surface area for absorption of nutrients. Fiber, though it is not an essential nutrient, is important for a healthy gastrointestinal tract. The microbes found in the cat's large intestine have the ability to ferment dietary fibers to short-chain fatty acids. Cells of the gastrointestinal tract are constantly dying and being replaced by new cells, which requires a lot of energy. The fatty acids produced are used as energy sources for these epithelial cells which line the gastrointestinal tract. As a result of the presence of energy from the fatty acids, colonic cell proliferation increases. Short-chain fatty acids production from dietary fibers have many other advantageous effects on the gastrointestinal tract. They increase motility by stimulating rhythmic contractions of the distal portion of the small intestine, which potentially decreases fermentation in the small intestine while increasing it in the large intestine for further fatty acid absorption. Blood flow to the colon also increases with the presence of short-chain fatty acids. These fatty acids also increase sodium absorption, which helps maintain normal electrolyte and fluid balance in the intestine, reducing the risk for diarrhea. These homeostatic conditions of the intestinal tract promote the growth of beneficial bacteria while inhibiting the proliferation of pathogenic ones. A healthy and balanced gut microbiome is important for maintaining a healthy digestive tract. Fibers promote bacterial growth and activity in the large intestine. It is essential for a healthy gastrointestinal tract to have a healthy and stable gut microbiota. The microorganisms present in the colon are responsible for the fermentation of the fiber into short-chain fatty acids and for the production of some vitamins. Prebiotics. Prebiotics are short-chain carbohydrates classified as fibers with an added aspect as they selectively promote the growth of beneficial bacteria. By promoting the health and proliferation of beneficial bacteria, they suppress the growth of pathogenic ones by outcompeting them. Insulin, galacto-oligosaccharides, lactulose, fructo-oligosaccharides, FOS, and monoligosaccharides, MOS, are all examples of prebiotics. Probiotics. Probiotics are becoming increasingly popular in the diets of felines. They are included in the diet to increase the number of bacteria and microbes that are normally present in a healthy gut. Probiotics are considered a supplement rather than part of nutrition. Therefore, there are no strict regulations to the amount of probiotics that should be included in foods. The function of probiotics goes beyond basic nutrition and has many benefits to the health of the organism. The use of probiotics can help in the prevention and treatment of certain diseases or disorders of felines. Examples include prevention of allergies, diarrhea, symptoms relating to stress, etc. The health of the cats is very much dependent on the fermentation that occurs through gut biota. The gut biota has an important role in the metabolism, absorption, and protective functions of the gastrointestinal tract. Felines have different gut bacteria than canines. However, the most common biota that are found in both felines and canines are firmicutes, bacteroidetes, proteobacteria, and fusobacteria. Although these are the most common types of gut biota found in felines, there are variances between independent cats. Each cat has their own unique and independent number and type of gut microbes. Antioxidants. Nutraceuticals such as antioxidants are considered to be additives of gastrointestinal diets to prevent digestive upset. Antioxidants have the ability to remove free radicals from the body which can cause damage to cell membranes, and are involved in chronic degenerative diseases. Free radicals amplify inflammation by causing release of pro-inflammatory cytokines. Free radicals can be caused by many factors such as stress, disease and age. Some oxygen-derived free radicals can produce ischemia in the small bowel and stomach of cats. Combinations of antioxidants have been reported to improve serum vitamin status, suppress lipid peroxidation and distributes the effects of exercise on the immune system. The most common antioxidants found in cat gastrointestinal diets are vitamin E and vitamin C. Vitamin E. The addition of vitamin E as an antioxidant in gastrointestinal health cat food diets can have a positive effect of improving the animal's immune function and prevent against infections. Vitamin E is a free radical scavenger that functions as a chain-breaking antioxidant to prevent free radical damage of cell membranes. Vitamin E aids in protecting cells from highly reactive oxygen species within the lungs, muscles, skin, brain, tissues and red blood cells. Supplementation of vitamin E in the diet benefits the immune system and improves resistance to infections and diseases. The National Research Council, NRC, suggested a ratio of vitamin E to polyunsaturated fatty acids be 0.6 to 1 to ensure enough vitamin E to combat any free radicals. Polyunsaturated fatty acids, PUFA, are prone to oxidative destruction in cellular membranes and increases the requirement for antioxidants. Vitamin C. Vitamin C, ascorbic acid, is a water-soluble antioxidant and a free radical scavenger where it will donate an electron to compounds with unpaired electrons or reactive but not radical compounds. Supplements of vitamin C reduce oxidative DNA damage in cats prone to kidney injury, and can be beneficial to add into diets for cats suffering from renal diseases. Vitamin C is not essential for cats as it is not required by the Association of American Feed Control Officials, AFCO. However, is commonly added into pet foods as an antioxidant. Ascorbic acid is known to not only be an antioxidant, but also to function in gene expression, as a co-substrate, and have unique biosynthetic pathways in different organisms. Fatty acids. A fat is a type of lipid which comes in the form of many different molecules throughout the body, and fatty acids are just one type of fat that can be found. Fatty acids come in a variety of molecular shapes, sizes and chemical compositions. They can also be divided into many different categories. Fatty acids can become attached to different molecules like carbohydrates or proteins and can elicit a wide range of functions in the body. Some of those functions include providing long-term energy storage, insulation, prevents heat loss, protects vital organs, helps transmit nerve impulses faster, structure, transportation around the body for nutrients and other biological molecules, and can also be precursors to other compounds in the body such as hormones, some of which are important for gut/immune/overall health. The length, degree of saturation and configuration of a fatty acid affects how it is broken down, absorbed and utilized in the gastrointestinal tract, GIT. Inflammation. Inflammation is the process by which the body begins to heal and defend itself from viral and bacterial infections and physical damage like burns or cuts. Typical signs of inflammation are redness, swelling, heat, pain and loss of function in the affected area. The inflammatory response is a normal response for the body to make when injured, but if the response gets out of control or becomes excessive, it can cause damage in the host with a wide range of effects from mild allergies to severe gut diseases. Inflammation is then an important response to focus on because it is very involved in the host's defense mechanisms and is often involved in gut diseases. The inflammatory process begins with intracellular and intercellular communication around the body using chemical mediators like chemokines and cytokines, which left unregulated can get out of control and cause excessive inflammation. Anti-inflammatories and the ratio of omega-6 to omega-3 fatty acids can influence the initiation and severity of the inflammatory response, controlling factors like intracellular signaling cascades and receptors for inflammatory molecules. Fat, adipose tissue, is also an important and potent mediator in the inflammatory process, and therefore regulation of fat stores is important in keeping the inflammatory response in the body under control. Nutrition and gut in cats. To achieve optimal cellular health, especially in the gut, and to maintain a healthy microbiome, proper nutrition is necessary. Nutrition is multifactorial and complex. Cats with GI diseases must consume an easily digestible diet with the appropriate nutrients provided by easily digestible ingredients and in the correct ratio, which is recommended to be fed in small portions frequently throughout the day, so as to not overwhelm the digestive system. It is also important for fat to be digestible because too much undigested fat that reaches the end of the digestive tract, colon, has the possibility of being fermented and can worsen the symptoms of gut disease and induce other reactions like diarrhea. It has also been suggested that cats should eat diets tailored to the section of the gut that is diseases. When certain nutrients like fructooligosaccharides, FOS, are included in the diet, the microbiome and fatty acid content are often changed for the better. An example would be less branched-chain fatty acids, BCFAs, which are more difficult and take more time to digest, are produced, and more short-chain fatty acids, SCFAs, which are easier to digest and are more readily available sources of energy which can be used for supporting cell turnover, keeping cells, like those found in the gut, healthier, thereby improving gut health and immune function, are produced. FOS can also impact production of other fatty acids. Fat digestion. Cats have a higher tolerance for a greater amount of fat in the diet, and although its digestion is complex and important, pertaining to its many functions and its influence on immune and inflammatory responses, fat composition in the diet appears to have a small effect on GI disease in cats. Taurine is an essential sulfur-containing amino acid for cats and some other mammals with many unique essential functions, one of which is the conjugation of bile acids, which are important in the metabolism of fatty acids. Fat levels are important so that the animal wants to eat the diet. So, although high levels of fat may be detrimental, too low a fat level in the diet and the animal will not eat it. Low levels may be only beneficial if the GI disease involves maldigestion, malabsorption, and/or influences the population of bacteria in the gut too much. Fatty acids and gastrointestinal health in cats. One group of fatty acids that is particularly important for gastrointestinal, GI, health is the essential fatty acid, EFA, group. All AFAs are polyunsaturated. They have more than one double bond in their fatty acid chain. AFAs are important to have in the diet in adequate amounts, especially for the cat, as since they are essential, meaning the body produces little to none, so it must be included in the diet, and cats have very low activity or simply lack the digestive enzymes to generate the AFAs that are important in mediating the inflammatory response. AFAs also vary in size, have many different functions, and can also be further divided into other categories, two of which are very important for GI health: the omega-6 and omega-3 fatty acids. The omega in the name denotes the position of the first double bond in a fatty acid counting from the methyl end. These fatty acids are most effective when present in adequate and appropriate balanced ratios dependent upon stage of life and production of the animal. One very important function of aphis is the production of eicosanoids, molecules that are important in immune and inflammatory regulation. Eicosanoids are like hormones and act in a local fashion with short lives. Different aphis have different effects on the inflammatory response. Omega-6 fatty acids at high levels can suppress the functions of the immune system, large part of which is located in the gut, and promote inflammation, platelet aggregation and hypersensitive reactions like allergies. Omega-3 fatty acids act in the opposite direction of omega-6 fatty acids by promoting anti-inflammation and depressing aggregation and immunosuppression. Ratio of omega-6 to omega-3 fatty acids can be changed using diet. Optimal ratio of omega-6 to omega-3 fatty acids is considered to be within the range of 5 to 1 to 10 to 1. The right ratio, different for everyone as everyone is unique, helps reduce inflammation and mediate immune responses as both omega fatty acids utilize the same enzymes in their metabolic journey. Some sources of omega-6 fatty acids include corn oil, sunflower oil and soybean oil. Some sources of omega-3 fatty acids include cold water fish oil, flaxseed, canola oil and soybean oil. Areas for improvement. There is very little research on cats in general, especially when diving into very targeted topics like gut health of cats and the effects of fatty acids of any length on their digestive system, especially cats with gut disorders. Gut diseases are common in cats, and it has been suggested that in the case of long-term GI diseases, diet is extremely important in modulation and manipulating the effects. Levels of fat included in the diet should be studied more and monitored, as not only does adipose tissue play a role in the inflammatory process, but it is also used as a palliative to make food more appealing. As fat is high in energy, overeating, which can cause an animal to become overweight or obese, is not uncommon in foods with high levels of fat, as fats are very palatable. Although not well studied, evidence from previous studies completed in animals and humans, who have similar digestive tracts to cats, suggest a proper ratio and use of omega-6 to omega-3 fatty acids will help mediate inflammatory diseases, especially ones present in the gut. Homemade food. Many pet owners feed cats homemade diets. These diets generally consist of some form of cooked or raw meat, bone, vegetables, and supplements, such as taurine and multivitamins. Homemade diets either follow a recipe, such as the BARF diet, which provides a series of options for the pet owner to make, or rely on the constant rotation of ingredients to meet nutrient requirements. A study was conducted that analyzed 95 homemade BARF diets and found that 60% of these were nutritionally imbalanced in either one or a combination of calcium, phosphorus, vitamin D, iodine, zinc, copper, or vitamin A content. Bisphenol A. A 2004 study reported that food packaged in cans coated with bisphenol A is correlated with the development of hyperthyroidism in cats. Food allergy. Food allergy is a non-seasonal disease with skin and/or gastrointestinal disorders. The main complaint is excessive scratching, pruritus, which is usually resistant to treatment by steroidal anti-inflammatory drugs. The exact prevalence of food allergy in cats remains unknown. In 20 to 30% of the cases, cats have concurrent allergic diseases, atopy/flea allergic dermatitis. A reliable diagnosis can only be made with dietary elimination challenge trials. Allergy testing is necessary for the identification of the causative food components. Therapy consists of avoiding the offending food components. Malnutrition. Malnutrition can be a problem for cats fed non-conventional diets. Cats fed exclusively on raw, freshwater fish can develop a thiamine deficiency. Those fed exclusively on liver may develop vitamin A toxicity. Also, exclusively meat-based diets may contain excessive protein and phosphorus whilst being deficient in calcium, vitamin E, and microminerals such as copper, zinc, and potassium. Energy density must also be maintained relative to the other nutrients. When vegetable oil is used to maintain the energy balance, cats may not find the food as palatable. Recalls. The broad pet food recall starting in March 2007 came in response to reports of renal failure in pets consuming mostly wet pet foods made with wheat gluten from a single Chinese company beginning in February 2007. Overall, several major companies recalled more than 100 brands of pet foods, with most of the recalled product coming from Menu Foods. The most likely cause according to the FDA is the presence of melamine in the wheat gluten of the affected foods. Melamine is known to falsely inflate the protein content rating of substances in laboratory tests. The economic impact on the pet food market has been extensive, with Menu Foods alone losing roughly $30 million from the recall. Some companies were not affected and utilized the situation to generate sales for alternative pet foods. Environmental impact. In a study on the impacts of the pet food industry on world fish and seafood supplies, researchers estimate that 2.48 million metric tons of fish are used by the cat food industry each year. It was suggested that there needs to be a more objective and pragmatic approach to the use of a limited and decreasing biological resource, for human benefit. Marine conservation activist Paul Watson argues that the reduction in forage fish such as those commonly used in cat food, sardines, herring, anchovy etc. negatively affects fish higher up the food chain like cod, tuna and swordfish, not to mention marine mammals and birds. Based on 2004 numbers, cats in the U.S. consume the caloric equivalent of what 192,000, 0.06555187%, Americans consume. While pet food is made predominantly using byproducts from human food productions, the increase in popularity of human-grade and byproduct-free pet food means there is increasing pressure on the overall meat supply. Protein. OFCO recommends 26% crude protein for feline diets on a dry matter basis. However, dry cat food from the top 3 cat food brands in Canada of 2010 contain 34%, 40%, and 36% protein respectively, on a dry matter basis. High animal protein in cat food has increased in popularity due to consumer demand for natural diets, in which protein content is usually much higher than the OFCO minimum levels. The effects of these trends results in a higher need for animal protein, which may have detrimental effects on sustainability. 6.4% of the USA's greenhouse gas emission is estimated to come from agriculture, and over 50% of the agricultural greenhouse gas emission comes from livestock. The large amount of livestock and fish protein used in pet food diets has been shown to have a much larger impact on the environment when compared to vegetable protein. Following only human trends, by 2050 approximately 1 billion hectares of land will need to be used for agriculture to sustain the human population. In 2015, an estimated 77.8 million dogs and 85.6 million cats were living in the USA. The consumer desire to feed their pets premium foods which advertise healthy and human-grade ingredients coupled with the increasing prevalence of pet ownership is causing increased pressure on the meat industry, which could result in increased land usage for raising livestock to meet the growing demand. In a study conducted by Oken in 2017, he suggests that if a quarter of all animal protein used in the food of American pets was human-grade, it would be equivalent to the energy needs of 5 million Americans. Oken uses an estimate of 33% of an animal's energy needs is derived from animal products. However, this is conservative in that many diets now have more than 33% of their diet in animal protein alone. Lowering protein levels in feline diets may help to improve the sustainability of both the human and pet food system by decreasing pressure on livestock agriculture and ultimately improving environmental effects. Nutrient chart. 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 Environmental effects. Nutrient chart.